Okay, so this is my first time being absent, so I usually make recordings for you guys so you don't miss out on your notes. Today we are covering extending addition to rational numbers and extending subtraction to rational numbers. We'll at least copy down the notes and we'll try and get some practice in whatever we can, and we'll review when I come back. So there's your notes, and if you need to, we could pause the video so you can copy this down. The sub should also have a copy of the notes to put on the document camera. So 2.1, extending addition to rational numbers. Go ahead and copy this down. This picture of group 1 and group 2 is in your textbook. A couple things I do want to talk about, but if you need to, pause the video. An algorithm, you'll hear math people say algorithm all the time. An algorithm is just basically a plan. It's something that you want to be able to do, and it's some things like formulas that we talk about. It's when you guys always ask, how do I do something? This is an algorithm that you're looking for. The commutative property has two basic types. There's addition and there's multiplication. The order doesn't matter. 3 plus 5 is the same thing as 5 plus 3. That one, it doesn't matter which order it's in. You still get the same answer. This is still 8 and that's still 8. Multiplication is much the same thing. It doesn't matter what order I multiply in. 3 times 5 is 5 times 3. They both equal 15, no matter which number comes first. Okay. So they call this the commutative property of addition and the commutative property of multiplication. When adding integers of the same sign, for example, positive 2 and positive 8, your answer, whatever it might be, will be a positive number. Okay. Negative plus a negative, your answer should be negative. Positive again and positive, your answer is positive. Negative and negative, your answer is negative. Now, that is not the same for when things are different signs. For example, here I have a positive and a negative. I have a positive and a negative. Here, I'm going to look for whichever number is quote unquote bigger. When I mean bigger, I'm talking about farther from 0. 8 is farther from 0 than 2 is, therefore this one is bigger. Okay, bigger, quotations. Not really larger, it's just farther away from 0. That means my answer is going to be a negative number. The negatives win, there's more of them than the other number. Here, same thing, my negative numbers are here, my positives are the 8, so whichever one has more, there's more positives, okay, that means my answer is positive. Positives here, negatives here, which one is bigger? 12, there's more 12s than 8s, so my answer is going to be negative. Same thing, opposite signs that are different, one positive, one negative, the positives are more, there are more of them, so they win in the answer, okay? And then I just subtract. There are more 8s than 2s. How much more? There are 6 more 8s. Here there are more 8s than 2s. How much more? Is I have 6 more. Same thing here. There are 4 more 12s than 8s, which means 4. And here the same thing. 12 and 8 give me 4. Positive 4. Now I could use my commutative property and rewrite these. Okay, I could rewrite these. I can move this number around for the addition. Okay, so when I'm adding numbers, my additive property, okay, this number and this number can switch places if I want, okay, because they're being added in between. This one really comes in handy when I have a minus in the front, a subtraction in the beginning, and then an addition in the back. Okay, it comes in really handy. I can rewrite this as positive 8 plus negative 2. That way it visually looks like and it feels like 8 minus 2, which gives me positive 6. Okay, now the addition doesn't move, but the two numbers around it do move. Okay, again, copy this down into your notebooks, please. And if you need to, pause the page where you can copy the rest, everything down. Okay, so this is in your textbook on page 33, question B, C, and I think on page 34 is question E. Okay, and when it asks you about your algorithm here on question C, does your algorithm for adding integers from question A work with the fractions and decimals? The algorithm that they're asking for, remember that's our pattern. Okay, the algorithm, that's a pattern or way of doing things. That was what we were talking about earlier, where I have same sign gives you same answer. Same sign answer. Okay, if they're different signs, abbreviate there, different signs, take sign, it's an N, sign of bigger number. That is our algorithm of bigger number. Okay, now does that work for decimals? That's what you're going to explain here in question C. Okay, so continuing on, we have 2.2, extending subtraction to rational numbers. So we did addition before. So if you remember here in our last equation, in our last lesson, or the lesson today, everything was addition. Everything was addition. Now it changes slightly when we do subtraction. We're going to do the same thing with signs that are different and the same with subtraction. A couple of things that are important is absolute value. We'll talk about this a little bit when I get back, but absolute value is the distance from 0. So this is -3, for example, is 3 spaces away, 1, 2, 3 spaces away from 0. Therefore, its absolute value is 3. The additive identity is a number that you get the same answer. So additive identity is always going to be adding a 0. Okay, for this one you must add a 0. So this one is add 0. It's the only way that you can add a number and get the same number in your answer. 12 plus 0 is 12. If I change 0 to anything else, I don't get 12 at the end. Okay, and additive inverse is where you add the opposite. Okay, so additive inverse means if I have 10 plus -5, this plus negative, that's my additive inverse. Okay, the adding the opposite. So yes, copy down this number line into your textbook, into your notebook, and we're supposed to write 2 equations. I kind of already have them down for you. This 7 right here represents going 7 in the positive direction in blue. That's my 7. And then I can go in the negative direction. That means go back this way 4 spaces and go -4. So this can be my -4, and this blue line is my +7. I circled this 3 because that's my answer. That's where my solution is, wherever I end up. Okay. Now the additive inverse portion right here is where I add the opposite. This represents the same thing as the subtraction idea. I have 7. I'm going to add in 4 negatives. Okay. If I add in 4 negatives, I'm going to go -1, -2, -3, -4. That joins this group of +7. Okay. And this here is my additive inverse right here. Additive inverse. Okay. So these two are the same thing. Adding a negative and subtraction represent the same idea. Okay. And then you're going to draw number lines for these for this equation, and you're going to have more than one line. Okay. I can start it off for you. Let's start off with our +7. Positives I'm doing in blue. I start at 0, and then I go to 7. That's my +7. I'll write that in. So +7. Okay, and then I'm going to add -2. So -2 is in red. So from here, I'm going to go back 2 spaces. I'm going to go to 5. So this takes me down to -2. Now I'm at 5. I'm not going to write it in, but that's where I'm at now. And then I go plus 3. Okay, plus 3. We'll do in blue because it's going the positive direction. I'm here at 5 now. I'm going to go up 3 spaces. It'll take me to 8. I'm kind of doing this on just stacking them. Plus 3. And you can figure out the rest and where you end. Okay, so I'm not much for giving explicit directions, but I think it might be helpful in working with positive and negative numbers. Okay, so here's our original equation. Subtract negative 12 minus negative 5. A whole bunch of negatives in there. And I kind of want to clean things up and simplify some ideas. Okay, so first thing I'm going to do, step 1, is to negative 12. So to this number, I'm going to find the opposite of positive 5. So the opposite of negative 5. The opposite of negative 5 is positive 5. So this here, okay, this idea, the opposite of negative 5, this idea changes into positive 5. Okay, I'm going to rewrite the equation with the simplified signs. I don't want two negatives. That's too confusing for me. So I just want to change this negative negative, or opposite of negative 5, into positive 5. From here I could just solve this. Okay, now there's two ways to solving this. I can write negative 12 and then positive 5. I can draw my number line. Okay, for example, let's make it really simple. Okay, I'm going to have 0, and then I'm going to go to negative 12, and then I can go positive 5, plus 5. So that's negative 12, that's plus 5, and I end up at negative 7. Okay, or I can rewrite it. Okay, I can rewrite it the other way. Some people like to see this 5, and my plus stays in the same exact spot right in the center. And then because it's my commutative property, I can move the entire number. I can move this negative 12. I know we said commutative property only works with addition, and this is still addition. I'm just adding this number instead, which so happens to be a negative number. I'm adding a negative number. Okay, and I can rewrite this the other way, and we can write our number lines, and we can start at 0 and go all the way to 12. Sorry, all the way to 5. We can go all the way to 5, and then we can go back 12 spaces, and we can get to negative 7 that way. Either one works. Okay, it just gives you options. Now you also have the option of writing this as 12 negatives. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 negatives, and then you can do 5 positives. 1, 2, 3, 4, 5, and these make again 0 pairs. 0, 0, 0, 0, 0, and then your answer 1, 2, 3, 4, 5, 6, 7 negatives. Okay, chip model. Okay, that's the other option. Okay, here's some practice problems. Go ahead and write these and solve these into your notebook. I'll leave an answer sheet with the sub so you can go and check them as well. Your homework for tonight will be, okay, so your homework will be the 2 worksheets that I handed out last class that I took back, which are Pizzazz. It's not pizza worksheets, it's Pizzazz, but this one's Punchline. Why did Farmer John ask the supermarket manager where the overalls were, and why can't bicycles stand by themselves? There should be one sheet for you guys to complete these 2 assignments. Okay. If you finish early, please don't disrupt the class. You can work on homework from another class. You can read your book. Please work quietly while others are finishing up. If you're not sure what to do, if you're having trouble, ask your sub, ask your neighbor, write down some questions, do the best you can, and then we'll review again what we came up with, what you came up with while I was gone. Also, Khan Academy, we are about week 6, so you should be close to 180 minutes or so if you're on task, maybe a little bit further. I think it's 23 skills, so you should be at least halfway, maybe a little more, maybe about 13 or 14 skills, 15 skills mastered. And that's all.